Hello everyone, welcome to Recitation station for CEE222 Water Resources Engineering, and this is week 10. This week we will have two questions, and the first question will be related to hydraulic jump. So let's get started. The number of question is 6.5.3. So in the question it says that a hydraulic jump occurs in a 5 feet rectangular channel, 5 feet wide rectangular channel, and the initial and subsequent depths are 0.66 feet and 3 feet. Therefore, we need to find the energy loss, and also we need to find the fluid number. So, as a brief summary, hydraulic jump is transition from supercritical flow to subcritical flow, or in other words, we can say that it is transition from high velocity flow to low velocity flow, or we can also say that it is from low stage supercritical depth to high stage subcritical subcritical depth. So we can say that this is from supercritical, and this side is subcritical depth. So during this transition, since we had higher velocity flow, and since we are going to lower velocity, we will lose our energy, so that we need to find this energy loss in this equation. So in equation 6.20, you will see a equation for the energy loss, and it includes both of these depths. So let me write it. Delta E, which is the energy loss, is equal to y2 minus y1 for y1, y2, and we have power of 3 here. And if we write everything we have, so we have 3, we have 0.66, again we have 4, 3, 0.66. So from this calculation, we can get delta E as 1.62 feet. So this means that while we are transiting from this flow, supercritical flow to subcritical flow, we are losing 1.62 feet energy. And now we need to find the fluid numbers. So as you know, to find the fluid numbers, we need to find velocity. So again, we have another equation, which is equation 6.16. It actually gives the relationship between unit discharge and these subsequent depths. So from here we can calculate the unit discharge, and then we can go to the calculation of velocity. So Q square over 32.2 is equal to 0.66 times 3. And this will give Q as 10.8 cubic feet per second times feet. Because this is unit discharge, it is the flow rate per unit width. So So we can calculate the unit discharge as 10.8. And also from the continuity equation, the velocity will be equal to q1 over y1, and this gives 10.8 over 0.66. Let me write it here. And the first velocity, which is prior to hydraulic jump, is 16.4 cubic feet per second. We calculated that because the question asks to find fluid number in the channel prior to this hydraulic jump. So we have 16.4. And now we can easily calculate the Reynolds numbers. So for the Reynolds numbers, we have velocity, we have G, and we have hydraulic diameter, which is D, and for this case it will be 0.66. And from here we will get 3.56. Let me do this. So this means that our fluid number is higher than 1, so it is super critical. So we are done with the question, and let me write another alternative equation. So as an alternative, we can use another equation. You can also find this equation in your textbook. So y2 over y1 is equal to one plus 8 fluid numbers square minus 1. Let me check it again. So yes, so if we replace everything here, so let's say we have 3, we have 0.66 is equal to 1 over 2. We have 1 plus 8 fluid numbers square minus 1. And this gives fluid number as 3.55, which is almost the same with the other method. So this is also super critical. Okay, let's continue with second question. This is question 6.5.5. So in this question, we are going to construct a specific energy curve and specific force curves. Therefore, I created this table, and we have specific energy and we have specific force, as you can see. And the width of the channel is 5 feet, and we have a rectangular channel, and it carries 40 cubic feet per second. We will need to use 0.5 feet depth increment up to 3 feet. So we will create these curves based on these depths, which is increasing from 0.5 to 3 feet. So let me get started with writing equations. The first equation, of course, will be specific energy, because we are asked to find that. So it is basically the velocity head plus depth. And the second equation will be the specific force. for this channel. So we have F plus rho unit discharge and velocity. Okay, so first let me write area of each depth. So it is basically 5 times 0.5. We have 5 times 1. We have 10 and 15. So after that, using the continuity equation, so we will divide 40 by these areas. So we have 16, we have 8, we have 5.3, we have 4, 3.2 and 2.7. So we'll calculate specific energy for each depth. So let me just try the first one. So we have 16 over 2 times 33.2 feet per square, second square plus we had depth as 0.5. It gives 4.5. So we will repeat this process for all of them. So let me write them directly. Okay, so based on these specific energy values, we can create specific energy curve. And finally, we are going to calculate the specific force. And the specific force is actually we have hydrostatic force for rectangular channels, and we have momentum flux, so it is actually specific weight over 2 plus this is remaining the same. So the specific weight is 62.4 pound per square feet. Again, I'm calculating this value for the first step. Plus we have density as 1.94 slag over cubic feet. And also for Q, I can do a small calculation. Q is Q over width. So it is basically 40 over 5. It is 8 cubic feet per second times feet. So it is 8. And we also have 16 for the velocity here. And this is going to give 256. So 256. And you can do other calculations as well. So you are going to just use these two columns to create specific energy curve and also to create specific force curve.